Hi friends, welcome to Talent Sprint's Banker's Choice program. In this session, we are going to discuss the most interesting and the most important topic from logical reasoning, that is syllogisms. Syllogism means inference or deduction, where a set of statements and a set of conclusions are given to us. We are supposed to assume the given statements to be true even if they vary from the commonly known facts, and then find out which of the given conclusions follow the given statements. So we can say that syllogisms is nothing but a logical argument where we are supposed to check whether the given conclusions follow the given statements or not. Let us now take an example to understand how does a question from syllogism look like. As I've already mentioned, in syllogisms, a set of statements and a set of conclusions is given to us, and we are supposed to decide which of the conclusions are true with respect to the given statements. Let us look at the given statements here. The statements are all cats are bats, and the second statement is all bats are tables. So as you can see here, there are two statements. The first statement is all cats are bats, and the second statement is all bats are tables. As I've already told you, the statements may vary from the commonly known facts. For example, in real life, there is no relationship between a cat and a bat. And similarly, there is no relationship between a bat and a table. But the statement says all cats are bats and all bats are tables. So though they seem to be completely varying from the commonly known facts, we have to assume that the given statements are true. So remember friends, whatever the statement is given, it has to be assumed to be true, even if it varies completely from the commonly known facts. Now, the given conclusions are some tables are bats, and the second conclusion is no cat is a table. So, we are now supposed to check which of these two conclusions follow with respect to the given statements. So, by assuming that the given statements are true, we have to find out which of these conclusions are true. To solve questions from syllogisms, the best method is to use Venn diagrams, where we draw the statements in terms of Venn diagrams or nothing but Euler's circles, and then check which of the conclusions are true. But before we understand how to draw Venn diagrams, let us first understand what are the various types of statements and quantifiers used in case of syllogisms. As you can see in the given statements, we have different quantifiers like all, some, no, etc. So let us first understand what are the different types of quantifiers we use. A quantifier is essentially used to express the quantity of a given set. So the different types of quantifiers that we have are all, no, some, every, few, etc. And these quantifiers can be basically classified into three types. The first one here is all, or it can also be referred as every. All or every. The second one is no or none. And the third one can be taken as some, or it is also referred to few sometimes. So these are the three different types of quantifiers that we use: all or every, no or none, some or few. Now whenever we use the term all, it refers to all the objects in the given set. Similarly, whenever we use the term no, it again refers to all the objects of the given set. For example, when we say all A's are B's, it means all the A's are B's. So each and every A in the set is B. Similarly, when we say no A is B or none of the A's are B's, it means each and every of the element in the set A is not a part of set B. So these two quantifiers, all or no, are referred as universal quantifiers because they refer to each and every object of the given set. The third type of quantifier that we have is some or few. For example, when we say some A's are B's, it means some of the elements in the set A are a part of the set B. Similarly, when we say some A's are not B's, that means some of the elements in set A are not a part of set B. So in these two cases, you can see that we are not referring to every object in the given set. So the quantifier some or few refers to a certain number of objects in the given set, and it is generally referred as a particular quantifier. Right? So we have two types of quantifiers in general: universal quantifier or particular quantifiers. All and no comes under universal quantifier as it refers to every object of the given set, and some or few comes under particular quantifier as it refers to only a particular number of objects in the given set. The other important point which we need to understand about quantifiers is the range of the quantifier sum. For example, sum generally means at least one. When we use the term sum, it refers to at least one. For example, when we say some A's are B's, it means at least one A is B. So minimum one A has to be B for this statement to be true, and maximum all the A's can be B. So from this we can understand that when we say sum, it can mean only one, and it can also mean all, as the minimum for sum is to be 1 and the maximum can be all. So very clearly, when we say some A's are B's, it may mean that one A is B or all the A's are B's. So you just remember that sum can be referred as 1 and also it can be taken as all. Let us now take the different types of statements that are used with the help of these quantifiers. Let us now understand the various types of propositions or statements used in syllogisms. Generally, there are 4 types of statements that are given in syllogisms, and they are as shown here. The first statement here is all A's are B's. That means all A's or every A is B. The second one is no A is B, or we can say none of the A is B. The third statement is some A's are B's, or we can also say a few A's are B's. The fourth statement here is some A's are not B's, and it can also be given as a few A's are not B's. So these are the 4 statements which are given in syllogisms. As I have already mentioned, the best way to solve syllogisms is to use Venn diagrams. So let us now understand how to draw Venn diagrams for these given statements. The first statement here is all A's are B's, or every A is B. Now this can be drawn in terms of Venn diagram as follows. Let us assume the smaller circle here represents the set A. Now if this smaller circle is taken completely inside the larger circle, that is B, we are following the given statement. If you see here, the smaller circle which is A is completely within the larger circle B. So we can say that all the A's are B's, or every A is B. So this is the basic diagram for the statement all A's are B's. There is one more Venn diagram which is possible for this statement. That is nothing but as shown here. Let us assume this is the circle which represents the set A. Now we can take the same circle to be the set B. And now if you observe, A and B are nothing but the same circle. So even in this case, we find that all the A's are B's, because all the A's are within B's, or they overlap completely each other. So these are the 2 types of diagrams which can be drawn for the statement all A's are B's or every A is B. Let us now look at the Venn diagram for the second statement, that is no A is B or none of the A's is B. Now here the simple way to represent this statement is take a set A as shown and then another set B as shown here. Now these 2 sets are completely disjoint. There is no overlapping between these 2 sets. So we can say that no A is B. And there is no other possibility to represent the statement no A is B with the help of Venn diagrams. So this is the only diagram which we have for the statement no A is B. Let us now move to the third statement, that is some A's are B's. The basic diagram which can be drawn for the statement some A's are B's is as follows. Let us assume this is the circle which represents the set A. Now we can have an overlapping here with another circle which is set B. Now from this we can say that some of the A's are B's. That is, the overlapping section is representing some A's are B's. So this is the basic diagram for the statement some A's are B's. But there are other possible ways of drawing some A's are B's. For example, let us assume this is the circle which represents A. Now within this circle, if we draw a smaller circle which shows B, we can see that some of the A's are B's. As you can see, these are the A's which are B's. So very clearly, some A's are B's is also followed in this diagram. And there is one more possible way of representing the statement some A's are B's. That is as follows. Let us assume this is the circle which represents A. And the same circle represents the set B. So these two circles A and B completely overlap each other. Now even in this case, you find that some A's are B's. Friends, we generally understand this to be all A's are B's. But as we have already discussed, the range of sum is from at least 1 to all. So sum can also be taken as all. So here you see all the A's are B's, and it can also be referred as some A's are B's. Remember, sum can also be taken as all. That is the reason we are able to take this third possible case. Let us now look at the various diagrams which can be drawn for the fourth statement, that is some A's are not B's. The first basic diagram which we can draw here is as follows. Let us assume this is the circle which represents the set A. Now we can have another circle representing the set B which overlaps with the set A. Now as you can see here, the statement is some A's are not B's. And in this diagram, we find that these are the A's which are not a part of B. So very clearly, some A's are not B's. So this is the basic diagram for the statement some A's are not B's. Again, there are other possible ways of drawing Venn diagrams for the statement some A's are not B's. The second case here can be as follows. Let us assume this is the circle which represents the set A. Within the same circle, we can have a smaller part which shows the set B. Now if you observe, the given statement is some A's are not B's. And in this case, we find that these are the A's which are not lying in B. So we can say that some of the A's are not B's. So even this diagram satisfies the statement some A's are not B. And the third way of representing the statement some A's are not B's can be taken as shown. Let us assume this is a circle which represents the set A. We can have another circle representing the set B, and here we have no overlapping between the set A and the set B. The given statement is some A's are not B's. Now as discussed earlier, we know that some can also be taken as all. When we say some A's are not B's, it can also mean all the A's are not B's. So here we find that all the A's are not B's, as there is no intersection between A and B. So even this diagram represents the statement some A's are not B's. So the point which needs to be understood here is some can also be referred as all, which we have already discussed. And that is the reason we are able to take the third possibility for the given statement some A's are not B's. So these are the different types of Venn diagrams that we can draw for the given statements. Now out of all these different diagrams, there is something called as a basic diagram. Basic diagram is nothing but which involves minimum overlapping between the two sets. So for the first statement, we have got two possible cases. That is, all A's are B's can be shown in these two ways. Now here we find that the overlapping between A and B is only this region. Whereas in this case, the overlapping between A and B is the complete circle. As we find overlapping is less in the first diagram, this is referred as the basic diagram. And this is the second possible diagram for the statement. So basic diagram is nothing but the diagram which has got minimum overlapping. Moving on to the second statement, we have got only one diagram, and here we find that there is no overlapping. So this itself becomes the basic diagram for the second statement, that is no A is B. The third statement is some A's are B's, for which we were able to draw three possible Venn diagrams. But the diagram which involves minimum overlapping is the first one. So this should be taken as the basic diagram. You can find that here the overlapping between A and B involves a smaller region. But when it comes to the second diagram, the whole of set B is overlapped within set A. So this has a larger overlapping when compared to the first one. And when it comes to the third one, we find that both the circles A and B completely overlap each other. So this has got maximum overlapping. So since the first diagram has got minimum overlapping, that is considered as the basic diagram. And for the last statement, that is some A's are not B's, the basic diagram is the first one. So this has to be taken as a basic diagram. One important point which we need to understand here is, in the first diagram, the overlapping between A and B is this region. But here, when we say some A's are not B's, the region which we are referring to is this one. That is the shaded portion. When it comes to the second diagram, you can see that the shaded region is the complete circle A except the region which is occupied by B. And when we take the third diagram here, the overlapping between A and B is not there. These two circles do not overlap each other. But the statement says some A's are not B's. Here, the region which we are talking about is the complete set A, as the whole set A is not B. So from this, you can understand that when we say minimum overlapping, we are actually referring to that region which is inferred from the given statement. So here the minimum overlapping diagram should be the first one. So after learning the various types of Venn diagrams and the basic diagram for each of these statements, let us now understand what can be the direct conclusions which can be inferred for each of these statements. Friends, understand that conclusion is the one which is true in all the possible cases. Now, if you look at statement 1, that is all A's are B's, we have got two possible diagrams. So, our conclusion should be the one which satisfies both the diagrams here. Now, if you look at both the diagrams, the conclusion which we can make here is some B's are A's. So, this is the conclusion for the statement 1, as this conclusion satisfies both the diagrams. If we observe the diagram 1, here we find that the larger circle is B, in which the smaller one is A. So we can say that some of the B's are A's. And even in the second diagram, you see that all the B's are A's. And we know that all is nothing but some. So here we can say that some B's are A's. Remember, when we say all A's are B's, the conclusion cannot be all B's are A's. Why? Because if we take the conclusion as all B's are A's, the first diagram fails. Here, all the B's are not A's, only some of the B's are A's. And here, some of the B's or all the B's are A's. So, a conclusion should be the one which satisfies both the diagrams. And that conclusion here is some B's are A's. So, for a statement which says all A's are B's, the direct conclusion which we can make is some B's are A's. Let us now understand what can be the conclusion for the statement no A is B. Here, we have got only one diagram. And the conclusion which satisfies this diagram can be taken as true. And we can understand that when no A is B, the conclusion will be very simple. That is, no B is A. So this is the conclusion for the statement 2. When we say no A is B, the direct conclusion is no B is A. Moving on to the third statement, some A's are B's. Now here we have got three possible diagrams. So the conclusion should be the one which satisfies all the three diagrams. Generally, when we see the statement some A's are B's, the conclusion which strikes to our mind is some A's are not B's. But friends, that is not the correct conclusion. Some A's are not B's is not possible in the third diagram. Why? Because here you can see all the A's are B's. There is no A which is not B. So here, when we say that the conclusion is some A's are not B's, it satisfies the first two diagrams, but it doesn't satisfy the third one. So some A's are not B's cannot be taken as a correct conclusion. Now, the conclusion for the statement some A's are B's, which satisfies all the three diagrams, is some B's are A's. Let us verify whether this conclusion satisfies all the diagrams or not. If you look at the first statement, that is the basic diagram, we find that this is the overlapping region, or this is the region which shows some A's are B's. And the conclusion is some B's are A's. So we can say that this is the same region which shows some B's are A's. So the conclusion satisfies the basic diagram. Moving on to the second one, here we find that B is inside the circle A. And as we have already discussed, some also refers to all. So here, all B's are A's is nothing but some B's are A's. So the conclusion satisfies the second diagram as well. And the third diagram here, as you can see, is B and A are shown by the same circle. That means all the B's are A's. Even in this case, the conclusion, some B's are A's, is true. Why? Because some can also be taken as all. So here we find that all the B's are A's. And the given conclusion is some B's are A's. So that satisfies the third diagram as well. So again, I would like to repeat the same point, that is, sum can be referred as all, and it can also be referred as 1, because the minimum value for sum should be 1 and the maximum value can be all. So the correct conclusion for the third statement is some B's are A's. Moving on to the fourth statement, that is some A's are not B's, you have seen that we can draw three possible diagrams. For such a statement, there is no conclusion which satisfies all the three diagrams. So we can say that there is no conclusion for statement 4, as nothing satisfies all the three diagrams. So there cannot be any direct conclusion for a statement which says some A's are not B's. Let us try to verify this point with the help of some conclusions. For example, for the given statement some A's are not B's, let us assume the conclusion is some A's are B's. That means when some A's are not B's, we can say some A's are B's. If we take some A's are B's, it satisfies the first diagram, as we can see some A's are B's here. Even it satisfies the second diagram, that is some of the A's are B's. But when it comes to third diagram, there is no A which is B. So our conclusion, some A's are B's, fails for the third diagram. So it cannot be taken as a conclusion. Let us now try with some other conclusion. Let us assume the conclusion for statement some A's are not B's is some B's are A's. Now when we take some B's are A's, it satisfies the first diagram, as some of the B's are A's. It satisfies the second diagram as well, because here all the B's are A's. So we can say some B's are A's. But again, when it comes to the third diagram, the conclusion fails, because our conclusion is some B's are A's, and we find here that no B is a part of A. So conclusion again fails for the third diagram. So very clearly, as you can see here, the conclusions some A's are B's and some B's are A's fails for the third diagram. So it cannot be taken as definitely true, as a conclusion should satisfy all the diagrams. Let us now try with some other conclusion. For example, the statement is some A's are not B's. Let us assume the direct conclusion is some B's are not A's. Let us now check the conclusion some B's are not A's satisfies which of these diagrams. Now, as you can see from the first diagram, very clearly some of the B's are not A's. So it satisfies the first diagram. The conclusion some B's are not A's fails for the second diagram, because here we find that all the B's are inside A's. That means all B's are A's, and our assumed conclusion is some B's are not A's. So conclusion fails for the second diagram. If we move to the third diagram, the conclusion was some B's are not A's, and it satisfies the third one. Here we find that no B is A, or all the B's are not A's. We can say that some B's are not A's. So the conclusion some B's are not A's satisfies the first diagram and the third diagram, but it fails for the second diagram. And likewise, if we try for any other conclusion, it definitely fails in at least one of these three diagrams. So as such, there is no conclusion which can be directly made for the given statement some A's are not B's. So friends, this is the most important part which we need to understand to solve questions from syllogisms. The various types of statements that we have, the various diagrams that can be drawn for each of these statements, and the direct conclusions which can be made for each of the given statements. Let us now understand how to use these conclusions for the given questions. For example, let us assume the question statement is all cricketers are footballers. Now when he says all cricketers are footballers, the direct conclusion which we can make is some footballers are cricketers. As for all A's are B's, the conclusion is some B's are A's. So whenever we have a statement which is similar to all A's are B's, the definite conclusion is some B's are A's. Similarly, if we move to the third statement here, some A's are B's. Let us assume some actors are cricketers. Now when we say some actors are cricketers, the conclusion which can be made is some cricketers are actors. And likewise, when we say no player is student, conclusion which can be made is no student is player. And for the fourth statement, that is some A's are not B's, there is no conclusion. For example, let us assume that some tables are not fans. Now when the statement is some tables are not fans, there cannot be any direct conclusion which can be made out of it. So this is how we are supposed to use these conclusions for the given statements. So this is how for each of these given statements we have a direct conclusion. And when two or more than two statements are given to us, we are supposed to make a consolidated Venn diagram and find out which of the conclusions given in the question are true for the given Venn diagram. After learning about the various types of statements and the direct conclusions which can be made, let us now understand what is meant by a complementary pair of statements. A complementary pair of statements is nothing but a set of two statements where if one of the statement fails, then definitely the other should be true. For example, when we toss a coin, there are two possible outcomes. Either it should be a head or it has to be a tail. So here, head and tail can be taken as a complementary pair. Now, for tossing a coin, if we say that the outcome is not a head, that means when the head fails, definitely the outcome should be tail. Why? Because there is no other possibility. Similarly, when we say that the outcome is not a tail, we can understand that it is a head. So this is how a complementary pair works. That is, when one of the statement fails, the other statement should be definitely true. So in all such cases where when one of the condition fails, the other condition has to be true is referred as complementary pair. So let us now look at the complementary statements in syllogisms. As we have discussed, we have got four types of statements, and these four statements can be divided into two complementary pairs. The first pair here is no A is B and some A's are B's. These two statements form a complementary pair. That means when the first statement here is false, the second statement should be definitely true. And when the second statement is false, the first statement has to be true. Let us understand this with the help of an example. No A is B. So this can be represented with the help of this diagram. This is A and B. As we have already discussed, the only possibility for no A is B is this Venn diagram. Now for this condition to be false, for this condition to fail, at least one of the A should be B. Only then we can say that no A is B is false. So when at least one of the A's comes under B, the condition fails. So, and that can be shown with the help of this diagram, that is A and B. Here we see that some of the A's become B. At least one is nothing but some, as we have already discussed. So the statements no A is B and some A's are B form a complementary pair. Why? Because when this is false, this should be definitely true. And likewise, for this statement to be false, this statement has to be true. That means when we say that some A's are B's is false, some A's are B's fails. In that case, no A is B should be true. Why? Because for some A's are B's to be false, all the A's should not be B's. That means no A should be B. And that can be shown with the help of that diagram. So very clearly, no A is B and some A's are B's forms a complementary pair. That is, when one of these statements fails, the other statement has to be true. The second complementary pair which we have is all A's are B's and some A's are not B's. Again, the same rule is applicable. When the first statement here is false, then the second should be true. And when the second statement is false, the first has to be true. Let us understand this with the help of diagrams. We know that all A's are B's can be represented with the help of this diagram. Here you see that all the A's are B's. Now for this condition to fail, at least one of the A's should come out. Only then all A's are B's become false. So for A, when it comes out, it appears as given here. Let us assume some of the A's have come out. Now in this case, we find that all the A's are not B's. So that is how when this condition fails, this becomes true. That is, some A's are not B's. Here we can find that some of the A's are not B's. And likewise, when this statement is false, this statement becomes true. That is, when some A's are not B's. For example, let us assume some A's are not B's should be false. For this to happen, all the A's must be B's. So all A's are B's and some A's are not B's form the second complementary pair. So we always need to take care of such complementary pairs when we are solving questions from syllogisms. Generally, two types of questions are asked from syllogisms. For the given statements, we either have to find out what are the conclusions or we have to find out what are the possibilities. So let us understand what is the difference between a conclusion and a possibility. A conclusion is nothing but something which is true in all the cases. So conclusion is nothing but which is definitely true or true in all the cases, definitely true in all cases. Whereas when it comes to a possibility, it may be true in only one of the cases. So possibility is something which is true in one of the cases, at least one of the cases we can say. Let us take an example to understand this. Let us assume the given statement is A is the wife of B. A is the wife of B. Now when the statement is A is the wife of B, the definite conclusion which we can make out of it, B is the husband of A. Why? Because when A is a wife, B has to be the husband, right? So we can say that B is the husband of A. Now here you can see that for the given statement, this is a conclusion. Why? Because this is definitely true in any case. Let us now take an example for possibility. Let us assume the statement is A is the son of B. A is the son of B. Now for this given statement, A is the son of B, we cannot have any definite conclusion. Like in the previous case, when the statement was A is the wife of B, there was a definite conclusion. That is, B is the husband of A. But in this case, we do not have anything which is definite. What we can only say here is, when A is the son of B, B is the parent of A. B is the parent of A. But whether B is a male parent or the female parent cannot be decided here. That means there are two possibilities. What are the possibilities? The first possibility here is B is father of A, and the second possibility is B is mother of A. So this is the basic difference between a conclusion and a possibility. As you can see, for this statement, we can make a definite conclusion. So this can be taken as a conclusion for the given statement because that is definitely true. But when it comes to possibilities, when the statement is A is the son of B, B is the father of A is a possibility, and B is the mother of A is the other possibility. So there are two possible cases here. And we cannot say that B is the father of A is definitely true. Why? Because B can be the mother of A as well. Similarly, we cannot say B is the mother of A has to be definitely true. Why? Because B can also be the father of A. So such cases are referred as possibilities, where there is not a definite conclusion, and this can be taken as a definite conclusion. So a conclusion is nothing but which is true in all the cases as shown here, and possibilities are nothing but which are true in any one of the cases. So this is the first case and this is the second case. Both can be taken as a possibilities. So in syllogisms, we have these two types of questions. Either we need to find out the conclusions which are definitely true, or possibilities which are true in at least one of the cases. Let us now take some examples to understand this. After learning about the various types of statements, conclusions and complementary pairs, let us now take up some examples from this topic of syllogisms. As I have already mentioned, generally there are two types of questions which are asked in this topic. One which is based on conclusions and the other which is based on possibilities. And we very well understand that conclusion is the one which is true in all the cases, and a possibility may be true in any one of the cases. So let us now take the first model from syllogisms which is based on conclusions. As you can see here, there is a set of statements and a set of conclusions. So assuming that the given statements are true, even if they vary from the commonly known facts, we need to find out which of these conclusions follow the given statements. So let us first have a look at these statements. The first statement here is all stamps are packets. The next one is some packets are buckets, and the third one is all buckets are tubes. So here we have got three statements. And the three conclusions are some tubes are stamps, some buckets are stamps, and some tubes are packets. So this is like a 3 by 3 question where we have three statements and three conclusions. Likewise, we can have a 4 by 4 question or a 2 by 2 question and so on. Now here, as you can see, in real life there is no relationship between stamps and packets, but the statement says all stamps are packets. And also, we don't find any relationship between buckets and tubes in the day-to-day life. But the statement here says all buckets are tubes. So even though these statements vary from the commonly known facts, we need to consider them to be absolutely true. And assuming that these statements are true, we now need to find out which of the conclusions follow the given statements. As we have discussed earlier, the best way to solve questions from syllogisms is to go by the Venn diagrams concept. So let us try to draw the Venn diagrams for these statements and check which of these conclusions are true. The first statement is all stamps are packets. So all stamps are packets can be taken as follows. These are the stamps which is completely encircled in packets. So the smaller circle here is stamps which is completely inside the packets. So we can say that all the stamps are packets. The second statement here is some packets are buckets. So some packets are buckets can be taken in this way. Remember friends, there are various ways to draw Venn diagrams, but generally we first need to look for the basic diagram. And we know that basic diagram is the one which involves minimum overlapping. So going by basic diagram, some packets are buckets can be taken in this manner. And the last statement is all buckets are tubes. So all these buckets are tubes can be taken as shown. So these are the tubes. So as you can see, the tubes and the buckets is represented by the larger circle and the smaller circle respectively. So all the buckets here are inside the tubes. Now with the help of this basic diagram, we need to check which of these conclusions are true. One important point to be noted here is to find out whether the given conclusions are true or false, not only the basic diagram but also the various other possible diagrams have to be considered. But in the beginning, we always go with the basic diagram. And if there is a need, then we can think of the various other diagrams. Now the first conclusion here is some tubes are stamps. As you can see from the basic diagram, the tubes is represented by this circle and the stamps here is as shown. And there is no overlapping between stamps and tubes. The two circles are completely disjoint from each other. So there is no relationship between tubes and stamps. But the conclusion says some tubes are stamps. So we can say that conclusion number 1 is false as it does not follow the basic diagram. So conclusion 1 is false. Remember, when a conclusion does not follow the basic diagram, it can always be taken as a false conclusion. Why? Because even if it is true in some other case, it fails in the basic diagram. We know that conclusion is the one which should be true in all the possible cases. So once it is failing in one of the cases, it can be taken as a false conclusion. The second conclusion is some buckets are stamps. So again, going by the basic diagram, these are the buckets and here we have the stamps. As you can see, there is no overlapping between buckets and stamps. But the conclusion says some buckets are stamps. So we can say that even conclusion 2 is false because it does not follow the basic diagram. So once the conclusion is false in the basic diagram, we need not worry about the other diagrams. Why? Because even if this conclusion comes out to be true in some other case, here it fails. And once it fails the basic diagram, we can say that it is a false conclusion. And the last conclusion here is some tubes are packets. From the basic diagram, these are the tubes and here we have the packets. And very clearly there is an overlapping between tubes and packets. So we can say that some tubes are packets follows the basic diagram because tubes and packets overlap each other. So these are those tubes which are also packets. But remember friends, just because this conclusion is true in the basic diagram doesn't mean that it can be taken as a true conclusion. Before we decide whether it is true or false, we need to keep in mind the other possible diagrams as well. So let us just try to verify whether this satisfies the other diagrams or not. For example, the last statement here is all buckets are tubes. So as these are the buckets, now while drawing tubes, if we try to draw it in this manner, we assume that these are the tubes. So even in this case, you find that all the buckets are inside the tubes. And now if we check the last conclusion, that is some tubes are packets, we find that yes, there are some tubes which are packets. This is the overlapping region. So these tubes which are shown by the red circle are the packets. So this conclusion number 3 is true even in the second possible diagram. So hence we can say that this is definitely a true conclusion. So conclusion number 3 is true as it satisfies the other possible cases. Even if you try to check with some other cases, it will always be true. So that's how it is. Not only with the basic diagram, a conclusion should be following all the possible diagrams. So that is the reason we say that conclusion number 3 is true. Before we take the next example, I would like to draw your attention to one important point here. If you try to look at the tubes which are shown by the red circle, we find that the conclusion number 1, that is some tubes are stamps, is true in this case. Why? Because here we find that these are the tubes and these are the stamps. So these tubes are stamps. So some tubes are stamps is true in the second diagram. But because conclusion number 1 fails the basic diagram, it cannot be taken as true. Why? Because it should be true in both the cases. Here we find that conclusion number 1 is true in the second case but not in the first case. So that is the reason once a conclusion fails the basic diagram, it can be always taken as a wrong conclusion. But only in case when a conclusion is following the basic diagram, we just need to verify with other possible diagrams as well. So here we can say that the answer is only conclusion number 3 is true, as the remaining 2 conclusions does not satisfy the basic diagram. Let us now take another example based on model number 1, which is about conclusions. The given statements here are some rivers are hills, no hill is taxi, all taxis are buses. And the conclusions are some buses are rivers, some taxis are rivers, and the last conclusion is no bus is river. So based on these statements, we need to find out which of these conclusions are definitely true. Let us first try to draw the basic diagram for the given statements. The first statement here is some rivers are hills. So some rivers are hills can be taken as shown here. These are the rivers and there is a overlapping between rivers and hills. So we can say that these are the rivers which are hills. The second statement is no hill is a taxi. So no hill is a taxi can be drawn as shown. There is no overlapping between hills and taxis. But while drawing the basic diagram itself, we need to understand that the taxis can also be taken on the other side. For example, we can also take the taxis in this manner. Even in this case, we find that no hill is a taxi. The only difference here is in the first case, there is no overlapping between rivers and taxis. But in the second case, we find that taxis and rivers overlap each other. So that is how, while drawing the basic diagram itself, we need to visualize the various other possibilities. The third statement here is all taxis are buses. So all taxis are buses can be taken in this way. All taxis are buses. And if we try to take all taxis are buses here, it can be taken as shown. So these are the taxis which are buses. Let us now see which of these conclusions are true. The first conclusion is some buses are rivers. Now if we go by the basic diagram, we find that there is no overlapping between buses and rivers. But if we take the second diagram into consideration, buses and rivers overlap each other. Why? Because this larger circle represents buses and rivers is as shown. So definitely some of the buses are rivers. But because the conclusion should be true in all the cases, here we can say that conclusion number 1 is false. Because it is true in the second case but not in the first case. So conclusion number 1 is false. The second conclusion here is some taxis are rivers. So if you go by the basic diagram, there is no overlapping between taxis and rivers. But if we take the taxis as shown by the red circle, we find that definitely some of the taxis are rivers. So this second conclusion is true again in the second case, but not in the basic diagram. So again, it can be taken as false because conclusion must be true in all the cases. And the last conclusion here is no bus is a river. Now if you go by the basic diagram, buses and rivers do not overlap each other. So we can say that no bus is a river. But if we take the bus as shown here, we find that there is an overlapping between buses and rivers. So again we find that the last conclusion, no bus is river, is true in the first diagram, that is the basic diagram, but it fails in the second diagram. So conclusion number 3 is also false. So friends, as we can see here, all the 3 conclusions given here are false either in the first diagram or in the second diagram. But then if we try to observe the conclusion number 1, that is some buses are rivers, and the conclusion number 3, no bus is a river, forms a complementary pair. We know that some A's are B's and no A is B is a complementary pair. So if we try to check these complementary pairs of conclusions from these 2 diagrams, we find that each of these conclusions is either true in one of the cases or in the other case. For example, if we take the first conclusion, that is some buses are rivers, you see that some buses are rivers fails in the basic diagram, but it is true in the second case. Why? Because here we find that some of the buses are rivers. So conclusion 1 is true in the second diagram, but it fails in the first diagram. But if we go for the complementary pair, that is the third conclusion, no bus is river, we find that no bus is river is true in the basic diagram, but it fails in the second diagram. So we very well understand that the buses can either be taken as shown here or as shown in the second case. So if we take the buses to be this one, we find that one of the conclusions is true, that is no bus is river is true. But if we take the buses as shown here, we find that some buses are rivers is true. So we can say that either conclusion 1 or conclusion number 3 has to be true. So the answer here should be either conclusion 1 or 3 should be true. Why? Because there are two possible cases to take buses. Either it can be taken in the basic diagram as shown here or as shown here. So if we take this one, one of the conclusions is true. And if we take the second one, the other conclusion is true. So here the answer should be either 1 or 3 is true. So again friends, as you can see, we need to go for the basic diagram, but at the same time check from the various other diagrams whether these conclusions are true or false. And whenever the given conclusions have got a complementary pair, like this, some buses are rivers and no bus is a river, we need to be careful and check whether these are true in either one or the other case. Let us now take another example from the first model of syllogisms. The given statements here are all roads are cars, no car is tree, some trees are jungles, and all jungles are rivers. And the four conclusions are some rivers are roads, some jungles are roads, some cars are roads, and the fourth conclusion is no jungle is road. Now as you can see here, if you observe conclusion number 2 and conclusion number 4, that is some jungles are roads, and conclusion number 4, no jungle is road, these two form a complementary pair. Why? Because this is in the form of some A's are B's and this is no A is B. So these two make a complementary pair. So we need to be careful whenever we have got a complementary pair in the given conclusions. Now again, let us start with the basic diagram for the given statements. So the first statement here is all roads are cars. So assuming that these are the roads and cars can be taken as shown. So we find that all the roads here are cars. The second statement is no car is tree. So as no car is tree, there should not be any overlapping between car and trees. So no car is tree can be taken as shown. The next statement is some trees are jungles. Now this particular statement, that is some trees are jungles here, can be taken in 2 or 3 different ways. For example, some trees are jungles can be taken as shown, where we find that some of the trees are jungles, or some trees are jungles can be taken with the help of this red circle. Here if we take this as jungles, we find that some of the trees are jungles. So we need to keep both the diagrams in mind when we are checking the conclusions. And the last statement here is all jungles are rivers. So all jungles are rivers as per the basic diagram can be taken as shown here. All the jungles are rivers. Why? Because all the jungles here are inside the rivers. But again, if we try to draw rivers in some other way, we can take it as shown. Because all the jungles are rivers, rivers can be shown with a red circle. So here we find that all the jungles are inside this rivers, which is shown by the red circle. For understanding point of view, let us take roads as RO and rivers as RI, so that we don't get confused in R and R. So friends, the black diagram what we can see here is the basic diagram, and these red circles are the additional diagrams which can be drawn for the given statements. Let us now see which of these conclusions are true. The first conclusion here is some rivers are roads. Now if you go by the basic diagram, roads are shown with the help of black circle and rivers are as shown here with the black circle. And we find that there is no overlapping between rivers and roads. So we can say that conclusion number 1 is false, as it says some rivers are roads and the basic diagram says no river is a road. The second conclusion is some jungles are roads. Now if we check with the basic diagram, jungles is as shown by the black circle and roads here is again the black circle, and there is no overlapping between jungles and roads. So very clearly no jungle is a road as per the basic diagram. But if we consider the red circle to be a jungle, we find that definitely some of the jungles are roads. We find that these are the jungles which are roads. Out of all the jungles here, these are the jungles which are roads. So we can say that conclusion number 2 fails in the basic diagram, but it follows the second diagram. So as such, it is false as per the basic diagram, but true in the second diagram. Now, as we know that a conclusion should follow all the possible diagrams, here we can say that even conclusion number 2 is false. Why? Because it fails in the basic diagram. Now, conclusion number 3 here is some cars are roads. Now, if you go by the basic diagram, we find that cars are shown by the black circle and roads are as shown. And definitely some of the cars are roads, as all the roads are inside the cars. So we can say that conclusion number 3 is true because some of the cars are roads as per the basic diagram. So conclusion number 3 is true. Even if we take some other case, we find that cars and roads will always be as shown. So we can say that definitely conclusion number 3 is true. And moving on to conclusion 4, it says no jungle is a road. Now going by the basic diagram, jungle is the black circle and road here is this black circle. There is no overlapping between jungle and road. So conclusion number 4 follows the basic diagram. But if we take the jungles to be the larger circle, we find that no jungle is a road fails in the second case. Why? Because jungles here is shown by the red circle and roads are inside the jungles. So definitely no jungle is road fails. Why? Because some of the jungles are roads. So we find that conclusion number 4 follows the basic diagram, but it fails in the second diagram. And because a conclusion should be true in all the possible cases, we can say that conclusion 4 is false because it is true only in the basic diagram but not in the second diagram. Now before we mark the final answer, we need to take care of the complementary pair. That is, some jungles are roads and no jungle is a road. From these diagrams, we find that some jungles are roads is possible in the second diagram because some of the jungles are roads, as we can see here, and no jungle is road is possible in the basic diagram. So here this complementary pair is like either conclusion number 2 or conclusion number 4 has to be true, because if we go by the basic diagram, conclusion 4 is true. If we go by the second diagram, conclusion number 2 is true. So here complementary pair, some jungles are roads and no jungle is road, is true in one or the other diagram. So we can say that either conclusion 2 or conclusion 4 should be true. So the final answer for this question will be conclusion 3 is true, definitely true. Why? Because it satisfies the basic diagram and other cases as well. But conclusion number 2 and 4 forms a either or pair. So we can say that 3 is true and either conclusion 2 or conclusion 4 is true. So that is the answer for this question. So friends, the only point that you need to remember here is whenever there is a complementary pair in the given conclusions, we need to be careful and check from the various possible diagrams. And in general also, whenever we are solving these questions, not only the basic diagram but the various possibilities have to be considered. Let us now take one more example from the model 1, which is based on conclusions. Here, as you can see, we have got 3 statements and only 2 conclusions. So this can be taken as a 3x2 question, where we are supposed to find out which of the conclusions follow the given statements. The statements here are all benches are cots, no cot is lamp, some lamps are candles. And the 2 conclusions are some cots are benches and second one is some candles are cots. So let us first try to draw the basic diagram for the given statements. The first statement here is all benches are cots. So it can be taken as benches which is completely inside cots. So we find that all the benches are cots. Second statement is no cot is lamp. So as there is no intersection between cot and lamp, these 2 circles must be disjoint. So no cot is a lamp. And the third statement is some lamps are candles. Now when it comes to the third statement, some lamps are candles, it can be taken in different ways. For example, as per the basic diagram, I can take the candles as some lamps are candles in this manner, where the overlapping is minimum. We can see that these are the candles which are lamps. But the other possible way of drawing candles is as shown by the red circle. Here you find that the red circle represents the candles. So some of the lamps here are candles. Now let us check which of the given conclusions are true from these 2 possible diagrams. The first conclusion is some cots are benches. Now if you look at this basic diagram, we find that all the benches are inside cots. So definitely some of the cots are benches, which can be shown by the shaded region. So we can say that conclusion number 1 is true as it follows the basic diagram, and even in the second possible diagram, the same cots and benches have to be taken. So definitely some cots are benches is true. The second conclusion is some candles are cots. Now if you go by the basic diagram, that is the black diagram here, candles is here and quartz is as shown here, which is completely disjoint from each other. So very clearly, no candle is a quartz. So the given conclusion, some candles are quartz, does not follow the basic diagram. But if we assume that the candles are as shown by the red circle, we find that some candles are quartz is true. Why? Because these are the quartz which are candles. So we can find that some of the candles are quartz. So very clearly, the conclusion number 2, that is some candles are quartz, does not follow the basic diagram, but it follows the second possible diagram. So here we can say that conclusion number 2 is false, because a conclusion must be true in all the possible cases. So conclusion 2 is false. So we can say that only conclusion 1 is true, because it follows both the diagrams. So conclusion 1 is true and conclusion number 2 is false. Let us now take another example from model 5, where the given statements are some buildings are sofas, some sofas are benches, and some benches are tables. And the conclusions are some tables are sofas and no table is sofa. So as you can see here, the given two conclusions form a complementary pair. That is, the first conclusion here is some tables are sofas, and the second conclusion is no table is sofa. So this is in the form of some A's are B's, no A is B. So this is a complementary pair of statements. And as I've already mentioned, whenever we have a complementary pair, we have to check all the various diagrams possible to find out which of these conclusions are true. Let us anyway draw the basic diagram first for these statements. The first statement here is some buildings are sofas. So buildings and sofas can be taken as shown here. So we find that some of the buildings are sofas. The second statement is some sofas are benches. So sofas and benches can be taken as shown here. So this is the region where some sofas are benches. And the third statement is some benches are tables. So some of these benches are tables can be taken as shown. So this is the region where some of the benches are tables. As we can see here, the given conclusions are with respect to tables and sofas. So let us understand in what other way can the tables be drawn. The last statement is some benches are tables. So the basic diagram is as shown here, but otherwise tables can be taken in this manner, where some of the benches are tables. So these are the benches which are going to be tables. So as per the basic diagram, this is the region where some of the benches are tables, and as per the other diagram, these are the benches which are tables. Now let us see which of these conclusions are true. The first conclusion is some tables are sofas. Now if you go by the basic diagram, tables and sofas are disjoint from each other. That is, they do not overlap. So some tables are sofas does not follow the basic diagram. But if we go by the second diagram, we find that some tables are definitely sofas. So conclusion number 1 is true in the second diagram, but not in the basic diagram. And if you look at the conclusion number 2, that is no table is sofa, it follows the basic diagram. Why? Because tables and sofas are completely disjoint. There is no overlapping. So no table is sofa is true as per the basic diagram. But if you look at the second diagram, no table is sofa fails. Why? Because we know that some of the tables are sofas. So very clearly the conclusion number 2 follows the basic diagram, but it does not follow the second diagram. So we find here that the first conclusion is true in the second diagram, but not in the basic diagram. And the second conclusion is true in the basic diagram, but it is false in the second diagram. So here, because this is a complementary pair, either this diagram or the other diagram has to be correct. So we can say that either the conclusion number 1 is true or the conclusion number 2 is true. So the answer for this question should be either 1 or 2 is true. So if the basic diagram is considered, we find that conclusion number 2 is true. And if the second diagram is considered, we find that conclusion 1 is true. So any one of these two have to be true. So that is the reason the answer for this question should be either 1 or the conclusion 2 is true. Remember friends, just because the given conclusions make a complementary pair doesn't mean that always the answer will be either 1 or 2 is true. In some cases, there may be a chance that only one of the conclusions is true and the other conclusion is false. So do not take it for granted that whenever there is a complementary pair in the given conclusions, the answer always will be either 1 or 2 is true. In some cases, the answer may be any one of them is true. So we always have to check with all the possible diagrams and only then find out which of these conclusions are definitely true. After discussing various questions which are based on conclusions, let us now take the second model from syllogisms, which is based on possibilities. Here, as we can see, a set of statements and conclusions are given to you, where the conclusions are actually in terms of possibility. And we are supposed to find out which of these possibilities follow the given statements. Now, as already discussed, a possibility is something which should satisfy at least one of the given Venn diagrams. The statements here are some papers are boards and no board is a card. And the given conclusions are all cards being papers is a possibility. And the second conclusion is all boards being papers is a possibility. Let me draw your attention to one point here. He is talking about possibilities. So very clearly, we just need to prove whether all cards can be papers. And we just need to prove whether all boards can be papers or not. Let us first draw the basic diagram for the given statements. Now, some papers are boards can be taken as follows: papers and boards. So as you can see here, there is an overlapping which shows some papers are boards. And the second statement is no board is a card. So no board is a card can be shown as given here. So we can see that there is no overlapping between boards and cards. But remember friends, there are various possible ways of drawing the Venn diagrams for these given statements. Now, instead of checking from various diagrams, let us look at the given conclusion, which is in terms of possibility, and understand that can we draw a diagram for such a possibility or not. For example, the first one is all cards being papers is a possibility. So as you can see here, we just need to check whether all cards can be papers or not. Now, if you go by the statements here, we know that no board is a card. So as per the basic diagram, cards have been represented as shown here. But it is also possible that we can take all the cards inside the papers. So here we find that all the cards are papers as they are completely inside the papers. And it also follows the given statements. So from this, we can say that all cards being papers is possible. Let me mention the same point again. Possibility is something which should be true in at least one of the diagrams. And here with this red cards, we can show that all cards can be papers. So conclusion number 1 is true. Let us now look at the second conclusion. All boards being papers is a possibility. So we need to find out whether all boards can be papers or not. Now, if you look at the given statement here, some papers are boards. Now, if we try to draw papers and boards as shown here, these are the papers and the same circle represents the boards. Remember, we have learned that the second diagram which is possible for some A's are B's is as shown here, where all the A's are B's or all the papers are boards as they are represented by the same circle. The point which we need to recollect here is that some starts from at least one and it goes up to all. So instead of saying some papers are boards, I can say all the papers are boards. And now the second statement is no board is a card. So no board is a card. Now if you try to look at this diagram, we find that all boards being papers is possible. Why? Because all the boards are papers. So we can say that even conclusion number 2 is true because it follows this diagram here. So this is how we just need to find out at least one diagram which can prove that the given possibilities follow the given statements. So after taking this example, we can understand that the basic difference between conclusion and a possibility is that a conclusion should be true in all the various possible cases, whereas a possibility may be true in at least one of the cases. So when it comes to possibility, we should be able to draw at least one diagram which can show that the given possibility follows the given statements. Let us now take another example based on possibilities. The given statements are all circles are squares, and the second statement is some squares are rectangles. And the given conclusions are, the first one here is all rectangles being squares is a possibility. So very clearly we can see that this given conclusion is in form of a possibility. That is, we just need to check whether all rectangles can be squares or not. And the second conclusion here is, can all circles be rectangles? The point to be understood here is, this is like a question that can all circles be rectangles? This is not a direct conclusion, but again it is a possibility. So here both the given conclusions are in the form of possibilities, because the first conclusion directly says all rectangles being squares is a possibility, and the second conclusion starts with the word can. So whenever we see that can all circles be rectangles, can all A's be B's, that should be treated as a possibility. So again, we need to check that can all circles be rectangles or not, or all circles being rectangles is a possibility. So this is another way of giving you a possibility. As discussed earlier, we just need to prove with at least one diagram that these given possibilities follow the given statements. Let us first try to understand the basic diagram for these statements. The first statement here is all circles are squares. So all circles are squares can be taken as shown here. And the second statement is some squares are rectangles. So some squares are rectangles can be taken as shown, where these are the squares which are rectangles. Now, the first conclusion here is all rectangles being squares is a possibility. Now, if we try to take the second statement, that is some squares are rectangles, we can also draw rectangles in this form. We find that some of the squares are rectangles, or we can say all the rectangles are inside squares. So some of the squares, that means these are the squares which are rectangles. So we find that all the rectangles being squares is a possibility from the second diagram. So the first conclusion here is true. Let us now look at the second conclusion, that is can all circles be rectangles. Here we need to check whether all the circles can be rectangles or not. Now if you go by the first statement, all the circles are squares can be taken as shown. The second statement is some squares are rectangle. That means these are the squares and we can take the rectangles in this form. Here we find that the given statements are followed in the diagram. We find that all the circles are squares and some of the squares are rectangle. These are the squares which are rectangles. So rectangles can be taken as in the green circle. Now if we try to look at the second conclusion, can all circles be rectangles? We find that all the circles are inside rectangles. So very clearly all the circles can be rectangles in one of the diagrams. So we can say that even the second conclusion is true. So even for this question the answer should be both conclusion number 1 and 2 are true. So both the given conclusions are possible in at least one of the diagrams. Let us now take the third example from model 2. The given statements are some paintings are drawings, all sketches are paintings. And the two given conclusions are all sketches are drawings and some sketches being drawings is possible. So as we can see here, the first conclusion says all sketches are drawings. Now this is not a possibility, but it is a definite conclusion. Why? Because neither the word possible has been mentioned, nor this conclusion is in terms of a question. So very clearly all sketches are drawings is like a statement and it has to be considered as a conclusion. So for this to follow the given statements, it must be true in all the cases, as we have discussed in the case of conclusions. And the second conclusion here is some sketches being drawings is possible. So here this is clearly a possibility. So for this to follow the given statements, it must be true in at least one of the diagrams. So here there is a combination of both conclusion as well as possibility. The first conclusion is actually in the form of conclusion and the second one is just a possibility. So for the first one to be true, it must be following all the diagrams, and for the second one to be true, it should follow at least one diagram. Let us now try to draw first the basic diagram for the given statements. The first statement is some paintings are drawings. So some paintings are drawings can be taken as shown here. We find that there is an overlapping between paintings and drawings, which shows that these are the paintings which are drawings. And the second statement is all sketches are paintings. So all the sketches must be paintings. So sketches here can be taken inside paintings. So all the sketches are paintings. Let us now see whether the given conclusions follow the given statements or not. The first conclusion is all sketches are drawings. All sketches are drawings. Now as you can see here, sketches and drawings do not overlap at all in the basic diagram. Why? Because they are completely disjoint from each other. So no sketch is a drawing. But the given conclusion says all sketches are drawings. So very clearly the first conclusion here does not follow the basic diagram. So this is false, or we can say this does not follow the given statements. Remember friends, this is a definite conclusion. So it must be true in all the given cases. And as it does not follow the basic diagram itself, we need not worry about the various other diagrams. Let us now look at the second conclusion here, which says some sketches being drawings is possible. So as we can see here, this is a possibility. And to prove this, we should be able to draw at least one diagram which says some sketches can be drawings. As we can see here, the basic diagram is as shown with the black circles. Now, if you try to look at the given statement, some paintings are drawings. The second statement is all sketches are paintings. Now here, if we take sketches in such a way that all sketches are paintings, as you can see by the red circle, all the sketches are inside paintings. So definitely all the sketches are paintings as shown by the red circle. And here we also find that there is an overlapping between sketches and drawings. So very clearly, some sketches being drawings is possible if you try to draw sketches in such a way that it overlaps with drawings. So the point here is, as per the basic diagram, sketches and drawings do not overlap. But if we try to draw sketches in such a way that it overlaps a little with the drawings, we find that some sketches can be drawings. And it also follows the given two statements. So very clearly, some sketches being drawings is possible in the red case. So we can say that conclusion number 2 is true. So the answer here should be only conclusion 2 follows the given statements. So that's our answer. Let us now take one more example from the second model of syllogisms. Here we have 3 statements and 2 conclusions. The given statements are all energies are forces, no force is torque, all torques are powers. And there are 2 conclusions. The first one is all energies being power is a possibility. So very clear, he is asking only about a possibility but not about a definite conclusion. And the second conclusion is all powers being force is a possibility. So even in the second conclusion we find that possibility has been mentioned. So these 2 conclusions here are in the form of possibilities. So let us try to draw the basic diagram for the given statements first. The first statement is all energies are forces. So it can be taken as energies which are completely inside forces. So find that all the energies are within forces. No force is torque. So there should not be any overlapping between force and torque. So we can take torque completely outside forces. And the last statement here is all torques are powers. So all torques are powers can be drawn as shown here. For the basic diagram, we find that all the torques are inside powers, and this is the basic diagram because it involves minimum overlapping. But otherwise, there are many other ways to draw powers. We can also draw powers with a larger circle which completely includes forces and energies. So this red circle here can also be the powers. So the black circles show the basic diagram, and the red circle which shows powers is another possible diagram for the given statements. Let us now see whether the given conclusions follow or not. The first conclusion here is all energies being power is a possibility. Now if you go by the basic diagram, energies and powers do not have any overlapping. So no energy is power or no power is energy. But if we consider power to be the larger circle, we find that all the energies being powers is really possible. Why? Because all the energies are inside powers. So we find that all the energies are powers. So very clearly, the first conclusion follows the second diagram. So we can say that all energies being power is possible. So conclusion number 1 is true. Moving on to the second conclusion, it says all powers being force is a possibility. So again we need to check whether all powers can be forces or not. Now if we try to observe here, if we take the powers as a larger circle, we find that all the forces are inside powers. So we can say all forces are powers, but we cannot say all the powers are forces. Even if we try to draw powers in some other way, let's say powers are as shown by the green circle. So we find that all the powers cannot be forces. The reason here is we very well know that no force is torque. There is no overlapping between forces and torque. And the third statement is all torques are powers. So definitely all the torques have to be powers, but torques and forces cannot have a common overlapping. So very clearly, always there will be at least some powers which are not forces, as in this case. Or we can find in the red circle that there are many powers which are not forces. So there is no way to find out a diagram which can say all powers can be forces. So we can say that all powers being forces is not possible by any of the diagrams. So conclusion number 2 is false. So the answer for this one is only conclusion 1 follows the given statements. Conclusion 1 follows the given 3 statements. So as you can see here, it is all about checking whether the given conclusions in terms of possibility is true in at least one of the diagrams or not. Let us now discuss another example from the second model of syllogisms, which is based on various possibilities. As you can see here, we have three statements and two conclusions. The given statements are: some oceans are seas, all oceans are rivers, no river is a canal. And the two conclusions are: all rivers can never be oceans. And the second conclusion is: all canals being oceans is a possibility. Now, as we can see here, the conclusion number 2 definitely is a possibility. Why? Because the word possibility has been given here. So we just need to check whether all canals can be oceans or not. And when we look at conclusion number 1, that is all rivers can never be oceans, we find that this is like a statement which simply says all rivers can never be oceans. So this is a definite conclusion, and second conclusion is in terms of a possibility. So for the first conclusion, we need to check all possible diagrams, and for the second one, if we can draw one diagram which proves this, we are through with this example. Let us first try to go with the basic diagram for the given statements. The first statement is some oceans are seas. So some oceans are seas can be taken as shown. So here we find that oceans and seas overlap each other. So some of the oceans are seas. The second statement is all oceans are rivers. So all the oceans have to be rivers. Now the second statement here can be shown in different ways, but going by the basic diagram, the rivers can be taken in this manner. So we find that all the oceans are inside the rivers. And the last statement here is no river is a canal. So there should not be any common part between rivers and canals. So we can completely take canals outside rivers. Now again, there are various ways of taking canals. We can have overlapping between canals and seas, right? But as we are going by the basic diagram, let us go for minimum overlapping. So no river is a canal can be taken as shown here. Let us now see which of these conclusions follow the basic diagram. The first conclusion here is all rivers can never be oceans. And as we have already understood, this is a definite conclusion. So it must be true not only in the basic diagram but in all the various possible cases. Now as the conclusion says all rivers can never be oceans, we find that here all rivers are not oceans. So in the basic diagram, this is true. All rivers cannot be oceans. So in the basic diagram, the first conclusion is true. That is, all rivers are not oceans. But if you try to draw rivers such that rivers and oceans share the same circle, because the statement says all oceans are rivers. So all oceans are rivers can be taken as shown by the red circle. So if we take the rivers as shown by the red circle, we find that all the rivers are oceans, or oceans and rivers are equal. But the first conclusion says all rivers can never be oceans. That is, it is quite opposite to the red circle as shown in the figure. So we can say that conclusion number 1 is false. Why? Because though it satisfies the basic diagram, it does not satisfy the other possible cases. And since it is a definite conclusion, it must be true in all the cases. So we say that conclusion 1 is false. Now let us look at the second conclusion. The second conclusion here is all canals being oceans is a possibility. So we need to check whether all canals can be oceans or not. Now as per the basic diagram, we find that there is no overlapping between canals and oceans. So the given possibility is not satisfied with the basic diagram. Why? Because the conclusion says all canals must be oceans. But here we find that canals and oceans do not share a common part. Now if we try to draw canals in various cases and check whether this is true or not, we find that no river is a canal. So canals can never come inside the rivers. It must always be outside rivers. So if we take canals anywhere else also, we find that there is no overlapping between rivers and canals. So from this we can understand that since canals cannot come inside the rivers, all canals being oceans is never possible. So even conclusion number 2, which says all canals being ocean is a possibility, is false. Why? Because it is not possible in any of the cases. So our answer for this question should be both conclusion 1 and 2 does not follow. Both conclusion 1 and 2 do not follow the given statements. So friends, with this example, we finish the topic of syllogisms. Practice well on this topic. Why? Because this is one of the definite questions which comes from reasoning. See you in the next session. Thank you.